and is being presented by Mubarak Vanada. And these are some of the contents that we shall be looking at in our presentation. And starting with the very first one, the introduction, we are seeing the reason why actually our study focuses on maize. Now, maize is considered to be one of the most important food crop around the world. It's consumed by millions of people around the world, especially in the poor countries or in the developing countries. It's considered one of the stable food crop. It's easily accessible. It has all the minerals, the vitamins, the proteins, the carbohydrates, and these help our children to grow. And for example, most of us have consumed it in schools, and it's you can see that it's really a very important food crop, and it's a source of income to many smallholder farmers in the East African region. Now, in the study carried out by McKee in 2016, it was discovered that in East Africa alone, there was a combined production of about 17 million tons of maize food crop. And you can see from here that maize actually plays a major role in the agricultural food market. It plays a major role for the well-being of people, especially those in the poor regions. Now, yes, we have seen that maize is important, but what is the problem affecting maize? Now, you can see that maize is actually important, but what would happen if at all there was no maize? You can see that there will be famine, there will be other diseases, and there are so many things that affect maize growth or production, and most of them are caused by fungus and other plant diseases. Especially, for example, if you see the maize streak and leaf blight, they're one of the diseases that are considered to be the most dangerous diseases to maize crop, and the in the in the in the East African region or in the Sub-Saharan region, and they are considered number one by farmers to be solved. Yeah, so maize streak and leaf blight are one of the most challenging diseases that farmers are facing in the East African region, and this poses a threat of food security, which can lead to dangerous famines. For example, we saw in Sudan there were people dying, and also loss of income and reduction in the GDP of the countries in the East African region. So solving these diseases is actually very, very important to not only the farmers but also to the people, to the poor people who actually consume this food crop. Now, our study presents the use of deep learning techniques. The reason why we employ the use of deep learning techniques is that currently, yes, farmers have these diseases have existed for ages, but the solutions that were used by farmers to solve these diseases, some of the solutions would involve using agricultural experts who would come to the farms or to the farmlands and inspect the plants to see which disease is actually affecting the plant. Now, this is not only not feasible for smallholder farmers, but it can be subjective to inaccuracies. You know, they say to human is to error. So not all agricultural experts are accurate, and even if they were accurate, not a majority of our farmers in the East African region are smallholder farmers. Not all of them will be able to have access to agricultural experts. Now, another solution that was used was the use of maize hybrids, but these have been proved to be very, very expensive. Maize hybrid seeds are really very expensive, and most of these farmers can't afford having them. So that's why we are using deep learning techniques. And one reason we are using deep learning techniques is because deep learning has actually demonstrated incredible potentials, and it has been used in the health sector. It has been used to monitor plant growth in the agricultural sector. So you can see that deep learning is actually very good, but there is a major drawback on these deep learning techniques. For example, one of the most important drawback is that it doesn't provide explanations to its predictions. For example, here we have demonstrated that yes, we are able to determine that this is maize leaf blight, but the person using the system doesn't know why it is maize leaf blight or why you should actually trust this system. So that's one of the major drawbacks that deep learning techniques have. Yes, they are good, but this is a major drawback that needs to be solved. So for that reason, that's why we are introducing explainable AI, which would be able to not only provide explanations, but it will also maintain a high level of performance. Now, the good thing about explainable AI is that when you provide the explanations, you can know how the model works or how it reaches to its predictions. So this can help you to know whether it's making biases or how it can be improved to be more accurate. So And also another thing is that people who are going to use the system should or must have access to know why actually how the system works. They should know why they should actually trust your system. So them being able to understand how the system works would be very good. Yeah, so here we have shown that machine learning models are opaque and initiative, meaning that people don't understand how they work. And so the ultimate goal of this project is provide a practical and effective solution for the diagnosis of maize diseases, which can benefit smallholder farmers and also other stakeholders like the researchers and other agricultural experts. The system should also be able to perform diagnosis with accuracy and also provide explanations. So the accuracy will be solved by using deep learning techniques, which are very accurate. Now on the problem statement part, the major the research problem for our studies to develop a diagnosis system that can accurately diagnose maize streak and leaf blight based on the images of the infected plants and also to provide a clear and understandable explanations for its diagnosis. Now, this is so because there has been a lack of an effective and easy to use diagnosis system for these diseases in resource limited settings. For example, most of these farmers are poor; they can't access the agricultural experts, so there is really a need to solve such a problem. And also, so as a result, the problem statement for this study is to address the challenge of accurately diagnosing maize streak and leaf blight diseases in a resource-limited setting or in a setting where people don't actually have the resources, and also using AI and plant transfer learning techniques to develop a diagnosis system that is not only accurate but should provide explanations and also should be easy to navigate around and use by these farmers, because as we know, most of these farmers are illiterate. Now, some of the research that has been carried out in this area, for example, Coates used advanced microscopy techniques to study the infection of Tusium in maize leaves. Chen and Wang developed a method for identifying maize leaves for him, he used PNN and image processing with SVMs. SVMs are also very good. Now, Doug developed a method for identifying diseases in corn leaves, and he had an accuracy of about 94%. Now, and many others. Now, you can see that these studies have shown that these systems can actually provide high accuracy. These machine learning systems can provide high accuracies in this disease diagnosis, but they are not suitable for large samples. Most of them have not been tested on large sample sizes or data. And for example, when you look at the advanced microscope, it is complex. There is no way you're going to take it to the farm to use a microscope on every maize crop. So that's a really major drawback. And also some methods, for example, the SVMs, yes, they have shown good performance, but they haven't been compared to see how they perform compared to other models. Yeah, so also there is a drawback on that. And also there is a lack of study that focuses on explainability and real-time guidance for farmers in diagnosis of and management of maize diseases. So far, no explainable techniques have been used to diagnose maize diseases. We tried looking up this and we didn't find any. So therefore, there is a research gap for the study that develops and compares a range of image classification techniques, including both traditional and machine learning. So no research has been done to compare how the traditional machine learning and deep learning techniques and deep transfer learning techniques compare, like how they perform when they are compared, and also while also prioritizing explainability and accessibility for farmers. Now, this raises some of our research questions. For example, what is the effectiveness of using deep transfer learning for image processing? How does the performance of a model trained from scratch compare to performance of pre-trained models? And also, we need to know how the explainable AI techniques can be used to provide clear and understandable explanations. or how a mobile application and an external database improve on the usability and accessibility of these systems, which is also an important area. We also want to know the impact of such a diagnosis system on maize cultivation and management. And so these research questions lead to our research goal or the objective, which is to develop an intelligent system that can not only identify the maize diseases with maize streak or leaf blight, but can also explain how the model made its predictions and provide real-time guidance. Now, by real-time guidance, we mean that yes, we have detected this is leaf blight. The farmer should know how he or she should treat the disease. So the system will be able to tell him how to counteract that disease and also show him how it came up to those predictions. And the specific objectives for this is to design an image classification model from scratch that can recognize the presence of maize streak and leaf blight. We shall also use transfer learning with VGG and VGG19 and ResNet 50 as baseline models. And also we shall compare their performance using the evaluation matrices. And also we shall select a best performing model and use explainable AI techniques. For example, we shall use feature importance analysis and salience maps to provide clear and understandable explanations. We shall also need to deploy the explained model on a mobile application. So these are some of the specific objectives. Now coming to our methodology, we shall begin with data analysis, where we shall analyze our images and remove any inappropriate images, and also we shall explore to see whether the classes in our data sets are balanced, or if at all there were any images that don't belong to a specific class. So all this will be done in the exploiter data analysis. Now after that, we shall design a traditional machine learning model, which means we shall design a model from scratch, and this we shall use convolutional neural networks to design it. Then after, we shall design two other models using VGG19 and ResNet 50 in transfer learning as baseline models. And after that, we shall evaluate the performance of these models. We select the best performing model, which will then be analyzed using the explainable AI techniques like LIME, SHARP, and ARP. Now, the good thing about LIME is that it provides explanations on how each feature um, contributed to the model's prediction. Or for example, the sharp. For example, also when we look at sharp for it shows for example, sharp uses the game theory to assign values to the different neurons within the model to show which neuron was based on when making the prediction. So after that, and the others, we shall explain most of these explanations are proposed, which we shall present later on. And after that, we shall convert our explained model into a TensorFlow JS format. The reason we're using TensorFlow JS is that it's the model will be somehow light, and we won't need to the farmer won't need to connect internet every time when he's trying to access the diagnosis system, so it will be on his phone. Now after that, we shall design design a web application. Now this will be designed using Django and React, and we shall use Firebase as our backend. Now Firebase comes with an NoSQL database, and here the reason we are including the database is because we want to build on our data sets. So the farmer will be given an option of sending the images he has diagonized to our external database, and this database will be interfaced by our web application. The web application will also be used to manage the different farmers. It will be like our admin panel to manage different applications on different mobile applications farmers are using. Now, these are some of the expected results from the models that we shall be testing. We need to know how the accuracy will be. We need to look at the F1 score. So basically here we are looking at the evaluation matrices that we're expecting from the models that will be compared. And also these are some of the explanations that we expect to get from the best performing model. Now, for example, here SHARP is being used to show how each feature contributed to the model's prediction. So these are like feature values. So this is what we expect to get from our model, from our study. And also another thing we expect to get to be an explanation framework. yes, if a farmer is able to diagnose the plant, he should have an interface to show him how the model came up to those predictions. Now, in conclusion, it is expected that the developed intelligent system will be able to accurately diagnose maize streak and leaf blight, and also the use of explainable AI will allow for clear understanding of the model's decisions. And also, we expect that the deployment of the model make it easy for these farmers to access these systems, because most of them are poor. So but we expect some of them to have mobile smartphones, so they should, if at all they have smartphones, they should be able to use this system. However, our system also has limitations. So for example, the performance of the model may be affected by variations in the quality and resolution of images, and also now these images will be used for training and testing, so some of them, the qualities are low because of the cameras that were used when taking those images in the data set. And also the data set is not very large. So this may not help our model to generalize well the crop diseases. So further research will be needed to address these issues. And also, we recommend some feature works for other researchers to collaborate with agricultural experts and to better understand what the farmers' needs, or what things farmers actually need when it comes to diagnosing and managing diseases. And also, they should consider developing more user-friendly interfaces for the mobile applications or web application. And also, more field tests need to be carried out in real-world setting to see how our model performs in real-world setting. And also they should explore the potential of integrating the model with existing farming management systems. For example, there is a system at the lab, at AI lab, which provides farmers with solutions in their natural language. It's an NLP system. So if at all they can integrate this into our system instead of using English, because most of these farmers are local farmers, they don't understand English, they're illiterate. So using such a system that can explain things in their local language would be such a good thing. Now, acknowledgement, we would like to express our gratitude to Dr. Joyce, because she gave us permission to work on this project. It was part of the lab's project, and the data sets we're using were collected by the lab. We also want to thank the staff at AI Lab, which helped us in guiding us in which areas to actually look at when solving this problem or when addressing this research. And also we thank Mr. Galiwango Martin, our supervisor, who has helped us in developing this proposal, and also any other person.